Okay, so today we're in section 2.7. We're finding the perimeter and area of similar figures. So just as a reminder, is similar and congruent, is that the same thing?
No.
Okay, so congruent is exactly the same. Similar is same shape, but not the same size. Everybody have your notes out? You guys have your notes out? Okay, then you need to be working on a blank sheet of paper. Blank sheet of paper, okay? If you don't have your notes. Okay? All right, so a couple terms you need to understand. All right, in order to understand what we're doing here, you have to know what perimeter is and what area is. So the perimeter is the distance around an object. Perimeter is the distance around an object. The area is the amount of surface space to fill an object. Okay, so we're talking surface here. The size of the surface of an object. Okay, all right, so two very big differences there. All right, so in example 1, we're going to use ratios to compare the perimeter. All right, if they are similar. Okay, so let's just read this to yourself real quick. Something in the direction should tell me whether or not it's similar. Are these two rectangles similar?
Yes.
No.
Yes.
Read it.
Yeah, the perimeter.
It says find the value of the ratio of the perimeters of the what?
Rectangles.
No.
Similar rectangles. Do you see that word? Guys, do you see the word?
Yes.
So because they are similar, it means that the value of the ratios of all their side lengths is going to be the same ratio. All right, so from orange to green, I'm going to put these side lengths into a ratio, which just simply means a fraction. From orange to green, 4/6. 4/6. Okay? Perimeter.
The right thing, right?
Yep.
Did you already go over the blank?
Yep.
It's a rounding surface.
Okay, so 4/6, all right, would be to compare the perimeter. We can reduce it. I'm going to need to double check because if you reduce it and then find the area, it actually makes it a different number. So we're just going to keep it 4/6 for now. If I reduced it to 2/3, 2/3 is essentially the same thing as well. But let's keep it 4/6. So the ratio, okay, so this is the ratio of my perimeter values. Okay, so here's why this is important. If this is my ratio, then what if I was given the length of the orange one, but I don't know the length of the green one? I can use the same ratio to set up a proportion. All right, and this is similar to number 5 on your homework from Tuesday, okay? But we probably needed to go over proportions to help you guys solve that one. So we're doing it now, okay? So we have orange over green. Does everybody agree that's the orange width over the green width? Equals the orange length over the green length that I don't know yet. All right. Now you can solve the proportion using cross products, meaning you're going to multiply 4 times L and 6 times 8 and set up an equation. Okay, so what's 4 times L, guys? Come on. What's 4 times L?
That's an L.
Yes, it's an L. Yes, it's a cursive L, so it doesn't look like a 1. All right, so we have 4L equals, what's 6 times 8? What's 6 times 8? 48. Okay, so now how would I solve for L? How would I solve for length? Divide both sides by 4. Okay, so the length of my green one, because these are similar figures, is 12. Okay, so I want you to look at something, guys. My length here is 12. What if I were to put this into a ratio as well? I should be looking at the same ratio. Okay, so let's go 8 over 12. Now we are going to reduce these. Okay, so the ratio of my lengths is 8 over 12. What would that be if I reduced it? Okay, I could divide top and bottom by 4, reduce it by 4 to get 2/3. What if I reduced 4 over 6? What would I get? 2/3. So my ratio of my width values is the same as my length values. All right, so if figures are similar, you can use their similarity ratios to solve for unknown side lengths or unknown dimensions. All right, how are we doing so far? Doing okay on that? Okay, so that's perimeter. So on example 1, this is just basically putting it into words. Okay, so I have to be able to read it and figure out what values we're talking about here. It says the height of figure A is what? What's the height of figure 8? Come on. 9 feet. The height of a similar figure, okay, so there's my clue right there. Similar figure is 15 feet, figure B. What is the value of the ratio of the perimeter? So this is important because if I ask you for area, all right, that's in the next example, then it's done a little differently. Okay? All right, so here we go. All right, so the value of the ratio of A to B is 9 over 15. 9 over 15, A to B, which reduces to, go ahead and reduce it. Is everybody working? You should have your pencil in your hand. Okay, pencil should be in your hand. What does 9 over 15 reduce to? Braden Harris, what do you think? 9 over 15, reduce it. Come on. What is it, Gavin? It's 3 over 5. That's it. That's the value of the ratios of the perimeters. Okay? Or of the height, I mean. Okay, so I could use that if I was solving for an unknown length, but I'm not doing that in this problem. Okay, example 2 now. What's the only difference between examples 1 and 2? What's the only difference? Okay, now I'm comparing what? Look at the title. I'm comparing area. Okay, so if I'm comparing area, it needs to look a little different. Now I'm still going orange to green. Okay, so I'm comparing the ratio, the value of the ratio of the areas. All right, so I have 6 over 10. Okay, and that's my perimeter. Okay, this is my value for my perimeter. If I was finding perimeter, I would be done. 6 over 10. But now I need to find the area, and my rule says that I take the value of my perimeters and I'm going to raise it to the second power. I'm going to square them. I'm going to square them. So what is 6 squared? What's 6 squared, guys? 36. What is 10 squared? 100. Okay? Now you can reduce it. You could reduce it if you wanted now. We know that 2 goes into it, 18 over 50. Okay? We know 2 would go into it again, 9 over 25. All right? The value of the areas. So just remember, guys, the only difference between perimeter and area, you still put it into a fraction for the ratio, but then you square the area. Okay? So essentially, you could find both in the same problem. All right? How do you guys feel about that?
A little bit better.
Okay? All right, all we're doing is writing a ratio from one figure to another and reducing it.
Is this the same thing as what we did, for example, 1?
Yep. Yep, except it was just perimeter.
But I also have a question about that.
Yep.
Why do we get...
In example 3, I'm going to pull together examples 1 and 2. Okay? So it's kind of a mix or a blend of what we did in 1 and 2. Now I'm going to look at this scenario. says a swimming pool is similar in shape. So because it's similar, my ratios are going to line up. Okay? So if I want to find the perimeter and area, I can use a proportion. Now, this is really important, guys. Your proportions can be set up in several different ways, and you can still accomplish the same result. The important part is, are y'all paying attention? I'm comparing the same unit on both sides of the proportion. That's the most important part. Okay? So what dimension am I given on both of the figures? Look here at the figures. What dimension do you see? Do you think that that's the length or the width?
Width.
What do you guys think? Come on, pay attention. It's the width, right, Lila? It's the width. Okay? So I have the width of the swimming pool and the width of the tennis court. I'm going to put that into a ratio. What does it look like in a ratio, Colin? 18 over 10. There we go. Okay, so I'm going to write 18 over 10, not reducing it. Okay? Now, because this is perimeter, do I need to square it? If it's perimeter, do I need to square these? No. Okay? So, does everybody agree that 18 was the pool dimension?
Yes.
Okay? And 10 is the tennis court.
Yes.
Okay? So this is pool over tennis court equals pool perimeter. Do I know the pool perimeter? Just put them up. Okay, so I don't know the perimeter of my pool. What's the perimeter of my tennis court? 60, right? 60. So I have pool over tennis court on both sides. Do you guys see that? Pool over tennis court. Now you can do your cross products to solve. 10 times P and 18 times 60. So 10 times P equals 18 times 60, which is 1,080. 1,080. All right. Okay, volleyball, same thing. Tennis court, volleyball court. All right, we have to get specific here. How do I solve for P? Angeline, how would I solve for P here? What do I need to do to both sides to solve for P? Divide both sides by 10. Okay? When I divide a number by 10, I'm essentially taking off that last digit, right? So P equals 108 yards. The swimming pool perimeter is 108 yards. I'm not going to make you find the length, but we could, right? If I know that the whole perimeter is 108, that means this side's 18. I could find the length. Okay? I could add those and subtract and then divide by 2. We don't have to do it though. Okay? All right, let's do areas. Okay? Find the area of the pool now. So I'm still going to use the dimensions that I know, width over width. Except now, what do I have to do to this ratio because it's area? Do you guys remember? What do I need to do to it? Raise it to the, what guys? Raise it to the second power. Raise it to the second power. Okay? So I'm going to square both of these so that now I'm comparing my areas. Equals the area of the pool over the area of the volleyball court.
Volleyball court, yeah.
Yep, there we go. We got it. Okay. But before I can cross multiply, I need to evaluate my exponents. Okay, so what is 18 squared? Is that going to be 36? No, that's 18 times 18. What is it?
324.
Yep. What is it? 324. So I have 324 over 100 equals A over 200. All right, I want you guys to finish this. Do your cross products and solve for the area of the swimming pool. Okay, so 100A
I got it right.
equals 64,800. Divide both sides by 100, which crosses off those last two zeros. A equals 648 yards squared.
If you don't put the yard square, is the answer wrong?
Yeah.
Yeah, you got to label these. You got to label these because area, we're always going to square the unit.
That is a lot.
All right. Yeah, that's a big old pool. Big pool.
Oh, no, I was talking
All right. Okay, any questions, guys? We're going to kind of jump into the classwork/homework for big ideas, number 17, if there are no questions.
No questions.
All right, no questions? Okay, all right, that's everything you need to know.